Here's your pre-calc lecture for 11.1.1. I'm not going to read all this out loud. I want you to look in your book and you can read all this. It's very interesting. I'm going to refer to problem 11-1, but I'm not going to read all the little story they have with it. So basically, you're used to graphing things in rectangular coordinates. Like you would just graph something, like 1, 3 would look like this. 1, 2, 3, right? You have X's and Y's and ordered pairs. So this is called the rectangular coordinate system, but there's another way to find a spot to designate a place on a grid, and so that is the polar coordinates. So with polar coordinates, I have this thing is like, they're kind of like vectors, like this is a magnitude and this is a direction. So let me just give you an example of how to graph this. You don't need any fancy polar graph paper at all. You can just, graph this on an XY grid, but it's that this is the length of the hypotenuse, or you could say this is the magnitude, and this is the direction. So what you do when you see this is you go think about opening up an angle starting from the positive x-axis and just open it up whatever angle measure it says. So this is pi over 4. So I can just kind of sketch in a little pi over 4, right? Pi over 4. And then this is just telling you that the magnitude is 3. So this length right here is 3. So an easy way, instead of making a bunch of triangles and using Pythagorean theorem, an easy way is just to use these little circles. And so sometimes you'll see this kind of grid paper like this. These are supposed to be perfect circles with radius 1, radius 2, radius 3. So if that's 1, 2, 3, this, like if I call this point P or whatever, this would be point P. Okay, so it's pretty simple, and you don't need the fancy paper for it, but I'm going to go through and show you some of these that are interesting. It says, let's put all these points on a graph. So point A is 3 comma pi over 4. Oh, that's the one I just did. So I find pi over 4, and then I count out 3 radii, 1, 2, 3, and that's point A. So I'm showing you the answers here. Letter B was negative pi over 6 and 2. So I'm going to go in the negative direction from the positive x-axis, or the positive horizontal axis, by pi over, what did it say? Pi over 6. So this is kind of nice because it's got the angles there for you, but if you didn't have this, you could still show that you went like that by pi over 6, and then you can show that you want 2 radii, so you go 1, 2. Okay, so you can just draw this on your paper. So that's 2 comma negative pi over 6. And then let's look at what happens on letter D. On letter D, they have negative, so they have pi over 4 as our angle, but then they have negative 3 as our radius, or our, if it was a triangle, it'd be a hypotenuse. So let's see how we can do that. So pi over 4 is our angle. So here's pi over 4, but instead of going out by 3, like 1, 2, 3, when it has negative 3, like if I want negative 3 comma pi over 4, I'm going to reflect across the origin. So I'm going to go this way. So I'm going to go, if this is pi over 4, I'm going to go the other way. 1, 2, 3. Okay, that's actually letter D. That is negative 3 comma pi over 4. Okay, so you have if the magnitude or the radius is a negative, you reflect over across the origin. Okay, and then let's look at letter H, because it says letter H occupies the same spot. Letter H occupies the same spot as letter D, and letter H is 3 comma 5 over 3 comma 5 pi over 4. So let's check that out. So I always use my angle first, and then I worry about the radii. So my angle is 5 pi over 4, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here's 5 pi over 4, and then I'm going to go out 3. So it occupies the same space as pi over 4 comma negative 3. Or sorry, negative 3 comma pi over 4. So that'll happen sometimes. I don't want to do every single one of them. Let's look at 11-2. So 11-2 says the locations were expressed in polar coordinates. Polar coordinates are plotted on a graph with a polar axis, which is the positive x-axis, and concentric circles centered at the origin. Polar coordinates are given as r comma theta, so r is the radius. If you're drawing triangles, it's the hypotenuse. If you're drawing vectors, it's the magnitude, which is the distance from the pole, and theta is the angle formed with the polar axis, which is the positive x-axis. This is directly related to your work with the unit circle. In the previous problem, some of the coordinates represented the same point, but in 2 different ways. So which points were the same? So we talked about that a second ago. We said 3 comma 5 pi over 4. So 5 pi over 4 is over here, and if I go out by 3 radii, I get a point, but I can get to that same point by saying positive pi over 4, and then have a negative 3. I would go backwards by 3. So I don't know if that makes sense. Hopefully that makes some sense to you. Using points from 11-1, complete the following problems. Letter A says use polar coordinates to write point B in at least 2 more ways. So let's see if we understood. So they said that letter B was 2 comma negative pi over 6. So I'm not going to use the fancy graph. I can draw my own. There's my polar axis. I'm supposed to go negative pi over 6. So this is my angle. I'll just sketch it in. It might not be perfect, but it's okay. And then, but my radius is 2, so I'm going to go 1, 2. So that's point B. Now, how else can I get there? Can't I go positive? Can't I go, if I go around this way, it looks like I made another radii. If I open my angle this way, like that, in this direction, then this is no longer negative pi over 6. This is going to be like, this would be 3 pi over 6. This would be 6 pi over 6. 9 pi over 6. 11 pi, this would be 11 pi over 6. Okay, so I can open up my angle 11 pi over 6 and give a positive 2. Or I can just keep adding 2 pi to it. So that's what I did over here, is I just added, I could go around twice. I could say, hey, you can go around once and then another 11 pi over 6. So I went over 2 pi plus 11 pi over 6 is what gave me the 23 pi over 6. And then if I want to do letter B, it says use polar coordinates to write point C in at least 2 more different ways. So here's point C. Do I need more paper? It's point C. And I'm going to go ahead and show what it looks like so that'll help me decide how I can write it in different ways. So point C, it looks like I have, the angle is 2 pi over 3, so that's 1, I think 2 pi over 3 is over here, right? See, you don't even have to have the fancy paper. I just know that, like, that doesn't look like pi over 3. This is 1 pi over 3, so this would be 2 pi over 3. Okay, so this is 2 pi over 3, and my radius is 1. So I'll just turn this into a radius right here. And that's point C. So what else can I do? Well, I can make it with, so that I have a -1. So if I take this 1 and I bring it across over here, and then if I can name this angle here. So this could be, this could be 5 pi over 3, I think. So I could say 5 pi over 3, because that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Here's 5 pi over 3. And then I can flip across the origin and get to that same point. And then I can also do it with a positive radius of 1, but I can come around, instead of coming around this way, I can come around backwards like that. And so what would that be? That would be 1 pi over 3, 2 pi over 3, 3 pi over 3. I think that would be -4 pi over 3. Okay, so you can, so if they give you this point, there's at least 2 other ways to get there. Or if you just want to be, keep it really simple, you can just keep adding 2 pi to 2 pi over 3. And then that way you're going 2 pi over 3 plus 2 pi, you're just going around, around once and then hitting it. So you can do it that way too. So that's 11-3, and I think that's all you have to do. Here's a nice little math notes box for you to read too.